In this video, we're going to talk about a theorem that's called Rolle's theorem. So recall from the previous section, the extreme value theorem told us that a continuous function on a closed interval from a to b must have both a minimum and a maximum on that interval. However, both of these values might possibly be endpoint extrema. So Rolle's theorem is going to give us conditions which guarantee a maximum or minimum that is an interior point of the interval. So Rolle's theorem says the following. It says if we let f be continuous on the closed interval from a to b and differentiable on the open interval from a to b, if f of a equals f of b, then there is at least one number c in the interval from a to b such that f prime of c is equal to 0. So what this looks like on a graph is the following. Basically, you've got two ordered pairs that have the same y value and a different a and b is your x. So what's happening here, if f of a is equal to f of b, and we know that we're continuous and differentiable on the open interval from a to b, so what this means is that the graph has to do something between these 2 points. Now, it could go up and come back down, in which case you have a relative maxima here, so the derivative would be equal to 0. It could go down and come back up to that point. Again, you have to be able to do this without picking up your pencil, but you would have a relative minima here, or it could go up, come back down, and then come back up, or vice versa. So you can see that you would have two places here where the derivative was equal to 0. So in that case, the derivative is still 0. Or it could just go straight across and be constant, in which case f of x is equal to some constant c, so the derivative is equal to 0 for the whole interval. So there's got to be at least one point inside that interval for which the derivative is equal to 0 if the two endpoints are the same y value. So let's look at an example. This one says find two x-intercepts of f of x equals x squared plus 6x and use Rolle's theorem to show that f prime of x equals 0 at some point between those two intercepts. So I'm going to start off by finding the x-intercepts. So we're going to set y equal to 0. So f of x is x squared plus 6x. And if I factor out an x, I get x plus 6. So I have x equals 0 or x equals negative 6 as my two x-intercepts. So that's going to create the interval from negative 6 to 0. So for Rolle's theorem, the other part of this problem, we need three things. Number one, we need f continuous on the closed interval from negative 6 to 0. Number two, we need f differentiable on the open interval from negative 6 to 0. Number three, we need f of negative 6 equal to f of 0. So let's go through and verify those. The first two are both true because f is a polynomial. So if you're trying to do this on a test, you do need to at least state that the reason why both of these things are true. You have to go through all three of the questions. Now the third one, we can just plug the numbers in and test them. So f of negative 6 would be negative 6 squared plus 6 times negative 6, which is 36 minus 36, which is 0. And f of 0 is 0 squared plus 6 times 0, which is 0 plus 0, or 0. Now that's no surprise. You knew that they were going to be 0 because they were both x-intercepts. So if you just wanted to state that they're both x-intercepts so the y values are 0, that's fine as well. But basically this gives us the conditions to say that Rolle's theorem says there is at least one c in the interval from negative 6 to 0 such that f prime of c equals 0. Now again, we haven't found it yet, but we do have a guaranteed minima or maxima on that interval. So for each of these examples, we're going to determine whether we can use Rolle's theorem or not, and if we can, we're going to find the value of c such that f prime of c equals 0. If not, we're going to explain why not, or why we can't use it. So we're going to go through the 3 questions for each one. So for f of x equals 8x, or x squared minus 8x plus 5, first I want to know, is f continuous on the interval from 2 to 6? And the answer to that is yes, because f is a polynomial. Number 2, I want to know, is f differentiable on the open interval from 2 to 6? And again, the answer is yes, because f is a polynomial, so that's gonna, anytime you have a polynomial, you're gonna have those 2 properties. And step 3, we want to know, is f of 2 equal to f of 6? So we do need to verify this, so we're going to plug those in. So f of 2 would be 2 squared minus 8 times 2 plus 5, which gives me negative 7, and f of 6 would be 6 squared minus 8 times 6 plus 5, which gives me negative 7 also. So the answer to this is yes. So Rolle's theorem applies here. So I'm going to find the derivative. F prime of x is equal to 2x minus 8. We're going to set that equal to 0. So 2x is equal to 8 and x is equal to 4. So that is our answer. Now, even if you knew that the derivative could be equal to 0, but Rolle's theorem doesn't apply on this problem, the most important part is figuring out whether Rolle's theorem applies. So check that first if that's what you're told to find. So in this example, again, we want to verify, is f continuous on the interval from pi to 2 pi? The answer to that one is yes, because it's continuous everywhere. Number 2, we want to know if it is differentiable on the open interval from pi to 2 pi. Well, the derivative of cosine is negative sine, so that is a yes. Number 3, we want to know, is cosine of pi equal to cosine of 2 pi? Well, in this case, the answer is no, because negative 1 is not equal to 1. So the answer here is no. So that tells us that Rolle's theorem cannot be applied here. And that's because f of a is not equal to f of b. So we're done. That's it. Now on this question, we have f of x equals tangent of x, and we're going from 0 to pi. So the first thing we want to know, is f continuous on the interval from 0 to pi? Well, the answer to this one is no, because f of pi over 2, which would be in that interval, would be sine of pi over 2 divided by cosine of pi over 2, which would be 1 over 0, so it does not exist. So Rolle's theorem cannot be applied because f is not continuous on the interval from 0 to 1. So if you get no to any 3 of the questions, you can stop right there and you know the answer is no.